Hey everybody, in this video we're going to be looking at the law of sines ambiguous case. Specifically, we're going to be looking at what conditions must be present for there to be no triangles, or one triangle, or two triangles. So if you want to follow along, links to the companion worksheet are in the description below. So what we're given here with number 1 is we're given that side B, that's lowercase, is 14 and angle A is 30. And we're going to assume 30 degrees. So if I draw my picture, here's a 30-degree angle, and we say that B is 14. Now, we don't know anything about side A. That's a mystery right now. But what we want to know is what possible values of A will guarantee the triangle have no solutions. Well, what we can do is we can say, well, what is the shortest distance between here and here? Well, that is the altitude, the straight line distance. And so what is that? Well, that's 14 times sine of 30 degrees. If we were to set this up as a right triangle, sine of 30 would equal h over 14. And in this case, that distance is 7. So what must be true about this side length so that we can't make a triangle? Well, that means it can't connect. It can't reach down. So in this situation, A, lowercase a, has to be less than 7. Now, some people would also say that you have to include 0 being greater than A. I don't think that's necessary, but for some people, they need to say that. But for a lot of courses, a lot of teachers, it's understood that if we're talking about a triangle, then the side lengths and the angle measurements all have to be positive. But if not, then it doesn't hurt to add in that extra little mark. Now, what about if it has only one solution? Okay. Well, there's actually two possibilities here. One possibility is that if we draw straight down, and so if we draw straight down, it's going to form a right triangle. And so in that situation, A is going to exactly equal 7. There's one. But there's a second option. So besides this, the other option is, well, it could be bigger, but it can't be big enough that it fits, but also less than 14. So in addition, we also have to say that A is greater than 14. Now, what does that look like? Well, it's going to look something like this. So here's 14. Here's 30, and here is side A over there. It's got to be long enough to connect, which it is, but it can't fit in here. Why not? Well, if it were to fit in between the height and the other side that we're given, then that means that the triangle could have two solutions. And I always tell students, if it can fit between these two numbers, whatever they are, then you're looking at a scenario where there are two solutions. So here, that means if A is something like this, so here's 30 degrees, here's 14, and what if we drew it here? That could work. Or we could draw it like this. That could work. Now, it has to be long enough to connect, so it has to be bigger than 7, but it also has to be short enough to be less than 14. So that means in this case we have 7, which is less than A, which is less than 14. Now, one thing I forgot, what if A exactly equals 14? Well, it wouldn't work over here. So I better go up here and modify that and say A is greater than or equal to 14. So on the next one, now we're given two side lengths. Side B is 14, side C is 17. And what are the possible values of angle B? Okay. So we have angle B over here. So side C is 17, that's adjacent to it. And we have 14 over here. Now, we don't know what angle B is, but what we're asking for is, well, What's going to cause it to have no solutions? Well, what if we draw down the height? Now, what if that height were 14? Let's see. Sine of b equals 14 over 17. All right. So that means b is going to be arcsine of whatever this ratio is, 14 over 17. And so what is that angle? Well, that's 55.43440 degrees. Now, what if the angle were bigger than that? What if it were bigger than 55.440? Well, that would mean the height would be bigger, and that means 14 wouldn't work. So if b were greater than 55.440, then we'd have to say, yeah, you can not close that triangle. It won't work. So what about if it has one solution? Well, the only way we can say it has one solution is if b exactly equals 55.440 degrees. Because if that's true, then that means 14 is just long enough to reach down and make a right angle with that. Now, logically, what we've covered is if b is greater than 55.44, we're going to have no solutions. If it's exactly 55.44, it's going to have one solution. If it's less than that, then that is what leaves us with two solutions. If b is less than 55.440 degrees. And so that's what this would look like if it were like this. So b is here. We have 17 and 14. Here we have b. We have 17 and 14 like this. Now, in order for that to be true, the height has to be less than what we set up above. And so in order for that to be true, b has to be less than 55.44 degrees. Thanks for watching. If you liked the video, give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.